Welcome to Solving Quadratic Equations for Pre-Calculus Math 11, and what we're taking a look at today is square roots and completing the square, which is section 3.3. In a general quadratic equation where ax squared plus bx plus c equals 0, when the linear term is 0, so when the bx term is actually 0, or b equals 0, the equation becomes ax squared plus c equals 0. And it can be solved by using square roots. Now, really what this comes down to is think about basic algebra. And in basic algebra, what we're doing is we isolate for the variable. Last lesson, we talked about if you have a quadratic equation missing the constant term, you can factor. Here's an example of us missing the linear term. So ax squared plus c equals 0. Pretty straightforward, isolating for the variable. So we're going to use inverse operations. Adding 5, we get 21. Dividing by 3, we get 7. And taking the square root, we get root 7. But remember, anytime you take the square root, we're going to have a little plus or minus in there. And you can certainly evaluate this on your calculator. I don't think you gain very much by doing that. But just to show you that we would get plus or minus 2.646. So both of those answers would work. Negative root 7 and positive root 7. Example B, 1b here, why don't you guys give that one a try? So what we would do is the outermost function here is the square, so we're going to take the square root, again, plus or minus, so we have root 10 plus or minus. The next step would be to add 3, so we have root 10 plus 3. Now that's a really nice exact value answer, there's nothing wrong with that. You could take that again and evaluate it, and you'd get negative root 10 plus 3, which would give you negative 0.162. Or you could take x and have it as positive root 10 plus 3, which would work out to be 6.162. Now those are fine answers. I like seeing them probably in radicals left out as exact value. There's more to more information, I think, there, less writing. Moving on, some quadratic equations cannot be solved exactly by factoring. In this case, we need to use the process known as completing the square. Now this is actually a really useful process. You're going to have to really memorize all these steps. So let's talk about completing the square. Let's say we have 2x squared minus 12x plus 4. Notice I don't have it equal to 0. I could have it equal to 0. It doesn't really make a difference here. The first step is really just kind of something that maybe helps you see it a little bit better. And really what I did is I said, you know what, let's move that constant term either further away or to the other side of the equation. It's not exactly a necessary step, but it kind of helps visually. So what do I mean by further away is, let's just write 2x squared minus 12x. And still write plus 4, but I'm actually going to put a little gap in there just to show that it's not going to really be involved in what we're doing here. If there is a coefficient on the x squared term, factor it out of the square and linear term. So what I'm talking about is we would normally group the 2x squared minus 12x. And we'd say any coefficient on x squared, in this case the 2, we're going to pull that out of both the x squared term and the linear term. And the plus 4 still sitting off to the side. Notice I don't factor out an x, I just factor out the coefficient. So I say here, in your head, divide the coefficient of the linear term by 2 and square it. So maybe off to the side here, I'm going to show you a little quick list of how to do this. I'm going to use L for the linear term. The coefficient of the linear term here is negative 6. I'm going to use H for half that. So half of negative 6 is negative 3. And I'm going to use S for square. So negative 3 squared is 9. So those are 3 important numbers here. What I want to do is I want to take this amount and add it and subtract it from the same side. So we're going to add or subtract that. And I'm going to do that by nestling it right next to the linear term. And we still have a plus 4. Now, effectively, if you take a look at plus 9 minus 9, what I've done is I've effectively added 0 to my equation. And the reason why I want to do this is I want to use part of that plus 9 minus 9 to form a perfect square. Now, you can't just randomly add numbers to an equation or to an expression. So we achieve the same idea by adding it and subtracting it. So it kind of works out really nicely. Next step, multiply the negative constant from above by any coefficient factored out in step 1. So really what this means is we're going to expand out the negative term. So I had a negative 9 there. That negative 9 times 2 is going to give me negative 18. And I still have a random plus 4 there. Complete the square using the square term, linear term, and positive constant. So we are going to create a perfect square. Negative 18 plus 4 is actually negative 14. I can just combine those two. Now, what perfect square did I have when I had x squared minus 6 plus 9? It is actually the half term from above, that negative 3. So x minus 3 squared, when you FOIL that out, gives you x squared minus 6x plus 9. So completing the square, why is it useful? Is because when we have a very difficult quadratic, we can go from 2 variables down to just one variable, one x value, and from there solve. So let's take a look at an example. So let's solve each equation by completing the square. So I have x squared plus 16x, and I'm just going to group the minus 7 by itself, or you know what, let's group it over to the other side. Save ourselves a little space. So we'll move the negative 7 over as a positive 7. What I do is I take a look at any coefficients on x squared. Just a 1, no big deal there. So we're going to take a look at the linear term, which is 16. Half that linear term is 8, and the square of that is 64. So 64 is the amount that we have to add in and subtract off. Now we're lucky here that there's no coefficient out front, so we don't need to multiply negative 64 by anything. We can actually just move that over to the other side. And we end up with adding 64 gives us 71. And now we can complete the square and turn that into x plus, it's that half term, x plus 8 all squared equals 71. And this should look a lot like solving by completing squares or by square roots like we did earlier in the notes. Take the square root of both sides, plus or minus root 71, and subtract 8. And again, if you want to evaluate that, I think we get answers of negative 16.426 and 0.426. So why don't you try that completing the square process on example 2 here. So example 2b, that is. Maybe make that listing of that L, that H, that S. I find that kind of useful. So hit pause now and try and do that. So if we move over to 13, we get 3x squared plus 42x equals negative 13. I need to factor out the coefficient of 3. 42 divisible by 3 is 14. And off to the side here, let me do my linear term. Coefficient is 14. Half of that is 7, and the square of that is 49. So 49 is what we're adding in there and subtracting off. X squared plus 14x plus 49 minus 49. And it still equals negative 13. Let us move that negative 49 out of the bracket, so we have 3 bracket x squared plus 14x plus 49, and negative 49 times 3 is going to give us a negative 147, and still equaling negative 13. Let's group that to the other side. As we also complete the square here, we have negative x squared plus 14x plus 49, and negative 13 plus 147 is 134. Our perfect square here again is that half term, so the x plus 7 all squared equals 134. And now we can isolate for x by dividing by 3. 134 divided by 3 doesn't really reduce that well, so let's just leave it like that. We can now take the square root. We have plus or minus root 134 divided by 3. And certainly solving for x, we would end up with plus or minus root 134 over 3 minus 7. So there's a good example of completing the square with that leading coefficient of 3. So let's take a look at one last example here. Why don't you go ahead and give that example a try. Hit pause now. So in this case, we can move the 13 over to the other side as negative 13. We're going to have to factor out the coefficient on the m squared. In this case, that's a negative half. Now, when you factor a half out of 5, it becomes 10, and it should be negative. So my linear term is negative 10. My half linear term is negative 5, and the square of that is 25. So that's really what we're adding or subtracting in, is 25. So negative half m squared minus 10m. And we're going to add 25 and subtract off 25. Again, that net zero addition is what we're looking for here. Negative half m squared minus 10m. We now move the negative 25 out. So as we take negative 25 out times negative a half makes it positive 25 halves. We multiply, of course. That equals, you know what, let's take that negative 13. Let's turn that into a fraction over 2. That would be 26 over 2 negative, because eventually I know we want to combine these things. We have a half. Our perfect square here is m minus 5. The 25 halves, or let's subtract over to the other side, make it negative 51 halves. And we've completed the square. Let's now solve for m. So we're going to divide by negative half or multiply up by negative 2. We get m minus 5 squared equals positive 51. Square root is plus or minus 51. And certainly adding 5 would give us that final answer. So we're looking at an m equaling plus or minus root 51 plus 5. And again, you could turn those into decimal values if you'd like. I prefer to see perfect exact value answers. This ends the notes for solving by completing the square. This completes the notes for solving by completing the square.